Okay, in the collision we looked at, the target ball and the cue ball. The cue ball approached the target ball. Target ball was pretty much stationary, although it's hard to make it stationary in these tables. Okay, target ball is pretty much stationary. The cue ball approaches the target ball, and the target ball goes off in this direction, and the cue ball goes off in this direction. So it's like this. I'm not sure I simulated that well with my hands, but you get the idea. Okay, so the direction of approach was not along the line joining the centers. Well, the target ball was stationary, so the only velocity we had prior to the collision was the velocity of the first ball. So I'm going to call that V1 initial, V1I. Now, if that's V1I, then, well, okay, there we have it. That's the definition. And we're going to assume that's 30 degrees below the central axis, just for some numbers, just so we can do a little bit of numerical analysis here. Or analysis by numbers is really numerical analysis. In terms of F12 and F21, then, what I'm going to do is I'm going to analyze the forces in this collision in terms of their components relative to this velocity. So I'm going to project these forces onto this velocity vector. Okay, so my question then is, what's the scalar projection of onto V, and actually that should have been V sub I, V1 sub I, right? But let's let let's let our V vector be our V sub 1 I vector. Okay, this vector. I kind of got careless with my notation here. But you know, it's going to be simple if we do that. And I think everybody understood what I was doing. And here I called it V1 and didn't call it V1 sub I. And again, being a little careless. But they all mean the same thing. V1 is the same as V1 sub I is the same as V. Okay. So again, what are these two projections? The projection of F12 onto V and the projection of F21 onto V, according to this picture. Well, according to this picture, I labeled it exactly backwards, so I'm going to fix that. It's not F21, this is F12, because that's the direction I chose for F12. So I'm going to change all these 2 1s to 1 2s right here. And then the 1 2s I got here should be 2 1s. And now that is a 2 1. And I changed the 2 1 to 1 2 here, but it should have been a 2 1 in the first place. So I've got 2 1 and I've got 2 1 here. Okay, sorry, that's a little sloppy and I was a little careless and I should have been more careful about that. And they're going to change up here too when I get to that picture, but I'm going to stay with these for right now. Okay. So again, in terms of F12 and F21, what are these projections? Well, F12 is this way. Here's your velocity vector, V1, V1I, V, whichever you want to call it. And here's the projection onto that velocity vector. I'm going to remove the subscript there to be consistent with what I have here. Okay? And the projection is very simply found by, you get your projection line, you get a right triangle, and you know what this angle is. It's the 30 degrees between horizontal and your V vector. Okay? So you get this right triangle, and the solution, well, the sides of that right triangle are square root of 3 over 2 F12, 1/2 F, it should be 1 2, And if you don't know about the sine and the cosine of a 30-degree angle, the exact value of the cosine and the sine, go back to 8th grade geometry, because that's where you first see it. And then it's reinforced in trigonometry. If somebody didn't put a calculator in your hands to avoid understanding things, that's not really the reason they did it. If they put a calculator in their hands, it's probably because they had no choice because of the SOL. Okay, well, anyhow, you should know the basic triangles, the 30-60 triangle and the 45-45-90 triangle. The ratios of the sides, the sines, and the cosines of those angles. The exact values by the Pythagorean theorem and equilateral triangles and similarity and stuff. Okay. In any case, we know that that's the right triangle and that these are the sides. Now, if it's F21, well, the way I've got it here, F21 is off that way. So this angle would be 210 degrees, right? Now, you could still use the right triangle, which would have sides of this length, but where the scalar projections up here are this square root of 3 over 2 F12, which is positive for this vector, and where this perpendicular component is positive for this vector. In this case, the scalar projection is going to be negative. Okay, now if you do the triangle, you don't get a negative from the sides. This is F21 here. This F12 shouldn't have a, well, okay, it's a vector, put an arrow on it, but let's not worry about that. Okay. Now, the scalar projection, since this angle is 210 degrees, is going to be negative because it's in the direction opposite the v vector. So the scalar projection will be negative square root of 3 over 2 times F21, I got that right. And the perpendicular component will be negative 1/2 F21. So now, when we do the picture, we get a picture that looks like this. And I said I was going to relabel these. So I think I'm going to do that before I start the next clip.